Okay, so here we will like to talk about the wave speed. Okay, the wave speed. As I mentioned before, the wave speed is c. Okay, the small c refer to the speed of light. The speed of light in vacuum. Okay, the speed of light in vacuum， 就是在这真空中啊。那在其他物质的话，这个速度会比较慢啊。或者在空气当中的话，跟真空是差不多的啊，跟真空是差不多的。And actually this C is equal to 1 over square root of mu naught epsilon naught. Okay, so two of the most important constant in the electromagnetism. Okay, the epsilon naught, the permittivity, and then the mu naught is permeability. Okay, so this is a 8.85 times 10 to negative 12, and then this one is 4 pi times 10 to negative 7. So if you plug in these two numbers here, and then you press the calculator, then it is more or less close to 3 times 10 to the 8th power meter per second. If in modern physics, like some particle physics, or let's say special relativity, we may need to use 2.99 times 10 to the 8th power, or even more precisely 2998 no 2997 92458 meter per second. Okay, so this like this. This is even more precise number for the C, but usually even for modern physics, 2.998 times 10 to the 8 meter per second is sufficient. Okay, so here let's see why and then it also tells you that the speed of the wave is actually this omega over k. So let's see what it means here. Okay, referring to this argument here. So so here so first of all, let's take x to be let's say t to be 0, then we will have and then we also let x to be 0, so the argument kx minus omega t will be a perfect 0. And here let's consider t to be capital T, which is the period of the oscillation. Then we will have kx minus omega t. We also hope this phi to be 0. Okay, Then we can slightly rearrange kx equals omega capital T, and then x over t will be omega over k, something like this. And then x. Okay, so this is somehow like the distance. Okay, the distance. And then this is the period, the time. Okay, so the displacement over the time, this will be a velocity. Okay, so in that case, this velocity will be omega k. Okay, because we doesn't want the phase to change. So it's like the phase is moving along the x-axis. Okay, so at t equals to capital T, which is a period, then x will be the phase 0, moving from the original point to that point, and then so this is like the displacement of that wave, and then so this v is like x over this capital T will be omega over k. So this is the speed of the wave, and and actually we know that the k is 2 pi over lambda. So it means omega over k is actually omega over 2 pi over lambda. So this is nothing but omega lambda over 2 pi. And omega is actually 2 pi f. 2 pi f is omega, and then times lambda over 2 pi. So 2 pi and 2 pi cancel, which becomes f lambda. So which is also the speed of light. So this some identity. Okay, so this c equals f lambda is quite important for when we talk about the wave. And so as here, so this omega over k is somehow like derived in reverse direction. Okay, so you start from this assumption and then you going backward, so that you can also know that the speed of light will be omega over k. Okay, so and then there is another property. Okay, so originally when you just look at this 33.1, 33.2, it is like EM, EB are just arbitrary number, but this is not true. In the EM wave, actually this EM and EB must have a fixed ratio 它有一个固定的比例值，那这个比例值刚好就是这个光速。 Okay, so this is also very important. We will also derive this one after this slide. I mean after this lecture slides. Okay, so yeah, so altogether we will derive the wave equation from the differential form of the Maxwell equation. We will get the wave equation, and then by solving the wave equation, we will get to know E and B will be like that, or maybe like cosine of this stuff and cosine of this stuff. Okay, so the only important point is that the E and B are in phase. 就是我的意思是书里面它都写 sine of 后面这个东西，那后面推出来的话，我会写 cosine of 这个东西。那只要它们是相位一样的话，就无所谓，at the same time, after deriving these two equations, and then we will also get k to be like that, and then we will also get the c will be like this, and then we will also get the ratio of EM/EB will be the fixed constant speed of light. Okay, so next we will we here introduce the energy transport and the Poynting vector. Okay, so actually the EM wave is propagating in the space. Okay, even in vacuum. It doesn't like the sun, need the air to propagate. Okay, actually the EM wave can actually propagate in even vacuum or in other materials. Okay, so actually the EM wave also carrying energy or power. Okay, and here we introduce a vector called the Poynting vector. Okay, which of course, it is a vector, so here we introduce the magnitude and also the direction. Okay, so simply speaking, the direction is the propagation direction 那 Poynting vector 的方向就是这个电磁波的传播方向。那刚才有提过，有稍微 recall 一下的话，就是传播方向 E 的方向跟 B 的方向，三个是两互相垂直的。Okay, so this is the direction of the Poynting vector, and for the magnitude, okay, it is the rate. You can also consider is somehow like the power, energy per time. Okay, which is the power. Okay, rate per unit area. At which energy is transported via and electromagnetic wave is given by the Poynting vector, And yeah, and also we will also explain why the Poynting vector is derived is like this. Okay, so this is so up to this moment you consider this is a definition, but you know why it would be like that later on. Okay, later on. Yeah, but yeah, so here we can see what we can see here is it is the E field crossed with the B field. Okay, so which means the cross product will be perpendicular to the E vector and also the B vector. Okay, so this is very straightforward, and it is normalized by this mu naught. Okay, so that the SI unit on both sides will equal. But yeah, you may still ask why this magnitude will be something like that. I will explain it a little bit later. Okay, so here one thing we need to know is that the E field and B field, both of them are sinusoidal， 是正弦的，无论是 cosine 也好，是 sin 也好，反正这个 E field 跟 B field 都是一个正弦波，所以这个 cross 完之后，它就是一个 cosine 的平方或者 sin 的平方，反正它是正的。And so it is like what you learned in chapter 31 about the AC source, like V times the I, okay, which is like a power, a sinusoidal power, or you can call it an instantaneous power， 就是一个暂时的一个瞬时的一个功率这样，但这个不是一个完全不是一个不完全是一个功率，它是多少能量在单位时间传播的量。 Okay, so here we will also introduce something called the time average. The time average rate per unit area. So which means we try to take the average. You try to integrate it for a period and then divide by that period. So this is the average rate per unit area at which energy is transported. Okay, and then we define this one to be as average, and which is called the intensity. Okay, 那中文就是强度嘛，就是一个就是一个电磁波的强度。Okay, so intensity of the wave. So which is I equals ERMS squared, and then over C mu naught. Okay, so yeah, so it is like here is E times B. Okay, and then both of them are sinusoidal. So you can simply imagine, after taking the average, it will be like E RMS times B RMS, and then with also this mu naught, and don't forget, EM over BM will be C. Okay, so EM is the magnitude. So in that case, ERMS will divided by BRMS will also be C. Oh, here ERMS is EM over square root of 2. BRMS is BM over square root of 2. Just following the RMS value in when we learn chapter 31. Okay, so here we also have this one. So which means BRMS will be ERMS over C. So in that case, we have ERMS square over C mu naught. Okay, which is the intensity of the EM wave. And another equation we concern is this intensity. The intensity will be the power divided by this surface area. Okay, so here what we assume is that the energy emitted by the light source S must pass through the sphere of radius R. Okay, so it means this one is the source of generating the EM wave. 这个是产生这个 EM wave 的源头那 中间一点源头的话，它就会往四面八方去传播。所以在同一个时间点的话，它就是每一个球体，但这里只能画同心圆，但是实际上是一个球面，就是经过一个 delta t 的时间到第一个圆，第二个 delta t 的时间到第二个圆，如此类推。那所以到每一个圆它就是原来的话就是 PS 是这个 S 所提供的那个功率就是每秒钟它的能量是多少。那然后它就会摊平在整个球面上面，所以这个 I 就会是 PS 除以这个4πr平方，就是这个球面的面积。Okay, so actually this one and this one will be equal to each other, and then we can do some calculation in the coming sample problem. Okay, so here let's take a look at this. So here it says when you look at the North Star, Polaris, 就是这个说北极星 you intercept light from a star at a distance of 431 ly. Ly is light year, 就是光年啊，光年的话就是光走1年的距离嘛 ，OK， 就是就是3乘以10的8次方乘以一天24小时啊，20乘以24乘以3600秒啊，然后再乘以365.25天啊，就是我们当1年有365.25天，OK， 因为4年一个闰年嘛，但每100年又不闰，那但是大概的话就是当做是365又1/4天。OK， 这个是北极星，所以如果你去下载一些什么星座的一些 apps 的话，你会看到北极星会很接近这个北极的位置，很接近了，它差一丁点啊，差一丁点。你总是找北边的话，就会看到这个北极星。Okay, you intercept light from a star at a distance of 431 light year and emitting energy at rate. Okay, this one, and that of our sun. Okay, P sun is this one. Okay, so this is even stronger. Okay, neglecting any atmosphere absorption 忽略一些大气的吸收。Find the RMS value of the electric and magnetic fields or B fields when the starlight reaches you. OK， 就问你这个来到的时候，这个 B field 跟E field 的强度。OK， so we will make use of the Purvis 2 formula. So I equals PS over 4πr square. Okay, so this is the one, and then the other one is ERMS square over C mu naught. Okay, so here we need some conversion because light year is not a SI unit. It's not an SI unit. So we need to slightly convert it to 431 times 3 times 10 to the 8th power, and then times 3,600 seconds per hour, and then times 24 hours per day, and then times 365.25 days per year. Okay, so this one will be 4.08 times 10 to the 18th power meter. Okay, so playing with this identity, this formula, we can have an ERMS to B, okay, moving C mu naught to the left side, and then take the square root on both sides. So we have a PS C mu naught, C mu naught over 4πr square, and then take the square root for the whole term. Okay, so this is PS is 3.9 times 10 to the 26th power times 2.2 times 10 to the third. Okay, so this is the PS. Okay, it just tell you it is a 2.2 times to the sun. Okay, and then this is P sun. So PS will be P sun times this 2.2 times 10 to the third power. And then times C is 3 times 10 to the 8th power, and then times 4 pi times 10 to negative 7. And then all over 4 pi times this out is 4.08 times 10 to the 18. Oh, sorry, this one should be 18 square, and then take the square root for the whole thing. And then this is 1.24 times 10 to negative third. Okay, you can use V over M or even N over C. Okay, just up to your choice. Okay, so this is the ERMS. Find the RMS value of the E field and B field. Okay, so for the B field, BRMS will be nothing but ERMS over C. Okay, so this is 1.24 times 10 to negative third over 3 times 10 to the 8th power, which is 4.1 times 10 to negative 12 T. Okay, Tesla. Okay, so this sample problem is quite simple, just to make use of these two formula for the intensity of the EM wave, and then we can also we also learn the unit light year. Okay, so and the remaining calculation is not difficult. Okay, so here we talk about the radiation pressure. Okay, so this one is special. Okay, because this chapter we call it EM wave. EM wave, but actually the pressure, okay, is not a property for a wave. Oh, and then especially here is talk about the force. 力不是一个波该有的一个特性不是一个波该有的特性。波就是正弦波，它是震荡就像一个弦那样但是这个 force OK 它实际上也有 force 所以这个是高中物理有提过的，这个叫做波粒二象性嘛duality duality。它有时候有波的特性，有时候有粒子的特性。Okay, so radiation pressure is a type of the particle. Okay, particle property. Okay, so it says when a surface intercepts EM radiation, a force and a pressure are exerted on the surface. 就会有一个力当这个电磁波打到一个面上面。那就会有一个力或者有一个压力会作用在这个面上面。If the radiation is totally absorbed by the surface, the force is F equals IA over C. Okay, so actually I don't know how to derive that. I don't know how to derive that. Okay, just believe it. This is true. And then there is another case. Okay, if the radiation is totally refracted. Okay, so the main difference is that the first case is totally absorbed, and the second case is totally refract. Okay, so here the force is 2 times, 2 times IA over C. Okay, 所以这个的话就是类似那种碰撞，就是那个是完全弹性碰撞，就是一个面打过来，如果你的 EM wave 过来，它就会有一个momentum 它也有一个 momentum。当它打到这个面上面，如果被完全吸收的话，那它会动量守恒嘛。但是吸收了，所以全部的动量都会作用在这个面上面，所以它有1倍的 这个力哦 ，IA/C 我不知道为什么。OK， 但是如果它是完全反射的话，哦，就是这有一个 P 啊，所以它就进入一个状态是，哦，它这个面就会带有一个 P， 它等于说有，它就是那个 F 等于delta P 嘛，啊，还是什么？我不知道，我不知道，我的力学不好了，反正就是哦，这个 P 就会完全给到这个面上面。OK，so and 如果是反射的话，哦，还是同样一个状况哦，一个波过来哦，它有一个动量啊，假设说它也这个面也是原来是没有动量的，那它就会变成一种状况的话，就是说哦，这个波要反向回去哦。这个波要反向回去，因为它没有变嘛，所以它的动量也没有变。那这样的话，就会有2倍的 P 会作用在这个面上面啊，所以这个力等于也是2倍啊，就是这个是完全弹性碰撞啊，就把这个 EM wave 弹回去哦，或者是你可以当做它是一个光子把它弹回去啊，这个吸收了的话就只有1倍啊。Okay, here we also in the textbook it also define the pressure. The pressure will be I/C. The PR will be 2I/C. So, but yeah, I think we won't use this pressure later on, so we can just forget it. Okay, so yeah, so this is a simple. Property for the simple particle property for the EM wave, and then here we go back to the wave property. Okay, so this one is called the polarization. In Chinese, this is called 极化。极化。OK， 极化的意思是虽然这边画的是好像 E 是一个方向 ，B 是一个方向，但实际上的话，一个光源随意打出来的话，它其实是所有方向的 E 都有，但是如果所有 E 都画出来，所有 B 都画出来的话，那就是一团你就什么都看不到。所以它这里也只画了一个方向的 E 跟一个方向的 B 但实际上的话，如果没有极化的光，一般打出来的都是没有极化的光，那它就会是。所有方向都有，就像这个状态那所有都画出来的话就一团乱。Okay, so the EM wave are polarized if there are electric field vector are all in a single plane, called the plane of oscillation. Light wave from common source are not polarized 正常的不是极化的。That is, they are unpolarized or polarized randomly， 就是随机的极化，就是没有极化。那如果有极化的话，那 E field 就只朝这个方向震动，那相应的 B field 因为要垂直它，所以也只朝这个方向，横的方向震动。传播方向的话，就是要不然是进去，要不然出来，那看你的那个 E cross B 是哪一个方向。Okay, so this one we call it a vertical polarization. It can also be horizontal polarization 就是它可以朝任意一个方向去极化的，是吧？如果是极化的话。Okay, so here we have some formula here. So first, it says if the original light is initially unpolarized, okay, initially unpolarized, 一开始没有极化的 the random transmit intensity I is half the original intensity I0. Intensity I0. Okay, which means at the beginning, okay, so this is the beginning, okay. Initially unpolarized. Okay, so it draw both vertical and horizontal polarization here. Okay, so and then this one we call the polarization sheet, or we can just call it a polarization filter. Okay, 就是一个可以说是一个滤光的滤波器这样的一个元件。Okay, so the sheet polarizing axis is vertical, OK， 所以它就是垂直画一些线，告诉你说，哦，这个是可以让这个入射光它变成一个，或者入射的电磁波变成垂直的极化的 ，OK。So the transmitted intensity is half the original intensity I0. So which means this one, the intensity is I0. Okay, so and then here the intensity is I equals half of I0. Half of I0. So I is half of I0. So which means we just assume half of the power or half of the intensity is vertical, half of the energy or half of the intensity is horizontal. So after the filter, half of it is filter, so the output is just half of the intensity of the input intensity. Okay, so and then the second one is if the original light is initially polarized. Okay, 一开始有极化的 and then the transmitted intensity depend on the angle theta between the polarization direction of the original light and the polarization direction of the filter. Okay, so here it says, okay, here the filter is vertical polarized. Okay, but the input, okay, the input is this one. The input is this one. Okay, so it has an angle theta between its input polarization direction with the direction of the polarization filter. Okay, so this is theta. Okay, so the output will be I0 times cosine square of theta. Cosine square of theta. Okay, so this is this makes sense. Okay, it's just like the E field. The E field will be like a cosine of it. Yeah, but the intensity will be E RMS square. So the output intensity will be like multiplying cosine square of theta. Okay, so these are two formula for the polarization. And then here, let's take a look at this sample problem. So here it says the figure shows a system of 3 polarization filter in the path of initially polarized light. Okay, the polarization direction of the first filter is parallel to the y-axis. That of the second filter is at an angle of 60 degree. Okay, 所以意思是第一个是垂直的，那第二个跟第一个有60度。逆时钟方向 counterclockwise from the y-axis, and that of the third filter is parallel to the x-axis. 那这个是水平的 what fraction of initial intensity I0. OK, 所以一开始输入的话是 I0 of the light emerges from the free filter system, and in which direction is that emerging light polarized. Okay, so so this is not difficult. So first of all, before filter 1, it is unpolarized. 一开始是没有极化的，是 I0 是这样。OK， 那我们就画十字两个方向的震荡。OK, after filter 1, it will be polarized. It will be polarized. 因为过完一个 filter 嘛，它就会 polarize. 那从没极化变成极化的话 I1. Okay, so here is I1. I1 will be half of I0. And then it is vertically polarized. Okay, so and then after the second one, after filter 2, okay, so it is still polarized. Okay, and then the I, so this is I1. Okay, I1 here, and then I2 will be I1 times 60 degree, okay, because this is 60 degree with the y-axis, and then I1 is oscillate along the y-axis, so there is a 60 degree between them. So I1 times cosine 60 degree square. And cosine 60 degree is 1/2. Okay, so which means it is 1/4 of I1, and I1 is half of I0. So this is 1/8 of I0. And then the direction will be 60 degree counterclockwise to from y-axis, okay, so finally after the filter 3, okay, so this is still polarized, okay, so I3 will be I2 times cosine of what degree? Okay, so this is horizontal 这个是水平的，这个跟 y 轴60度，所以跟 x 轴是30度那这个是水平的是 x 轴，所以是 cosine 30 degree and then square. Cosine of 30 degree is square root of 3 over 2. Okay, so this is 3 over 4 I2, which is 3 over 4 times 1/8 of I0, which is 0.094 I0, like this. Okay, so this is polarized in x-axis. Okay. 所以这个有点怎么说？有点违反直觉，因为你感觉上它有一个垂直的，有一个横的，那是不是垂直的跟横的全部都滤掉？它也不是，它中间加了一个60度斜的给它的话，它还是有一些能过，